Welcome to lesson 4.4. We're going to continue to look at increasing and decreasing functions and using the first derivative test. We've got two examples we're going to do in this video, number 4 and 5 in your workbook. We'll start with 4. In this case, we begin by looking for the derivative. Remember, in both of these, we're looking for the intervals where it's increasing and decreasing and our extrema points. So to find the derivative of this is going to be a combination of product rule and chain rule. Our product rule is the negative x and the e to the negative 2x squared. So we'll start off with that. This is going to be a negative 1 times our e to the negative 2x squared. We're adding to that. In this case, it's going to be a negative x. And then this is where the chain rule comes in. The derivative of e to the negative 2x squared is e to the negative 2x squared times the derivative of that, which is times a negative 4x. Okay, we definitely want to simplify this just a little bit. If we were to kind of clean this up, this is going to be a negative e to the negative 2x squared plus, in this case, we've got a 4x, a negative 4x times a negative x. So this is actually going to be plus 4x squared times e to the negative 2x squared. Now, if at first you don't see ways to simplify this, sometimes you can move the terms around, factor things out. In this case, I can see that there's an e to the negative 2x squared in both of these. So I'm going to go ahead and factor that out, and that'll help me figure this out. So e to the negative 2x squared. And this is going to give me, in this case, negative 1 plus 4x squared. Now, I would really like to switch these around, which I can do. And I'm going to do that now. I'm going to put the negative 1 in the back and the positive 4x in the front, 4x squared in the front. And what that's going to do is hopefully when you look at this, you can recognize it as a difference of squares. And that's going to help us when we look for our critical numbers. Now in this case, we're looking for our f prime of x equal to 0. We're looking for those numbers. There are no values that we have to worry about it being undefined on. So our primary focus is going to be this where they're equal to 0. Now, if we look at this exponent part here, the e to the negative 2x squared, there is no point on that line that's going to ever cross the x-axis. It gets very, very, very close, but it'll never cross. So there's not going to be any zeros come from that. Our zeros are going to come from this 4x squared minus 1. And once again, this is a difference of squares. We have a 4 is a square, x squared is a square, and 1 is a square. So we could look at this as 2x minus 1 and 2x plus 1. And that's going to give us our x values, the critical numbers of plus and minus 1/2. Okay, this happens by moving the 1 over and then dividing by 2 in both cases. So we've got two critical numbers. There isn't a limit on our domain, so we're going to go ahead and just kind of create these two somewhere in here. This is a negative 1/2. We'll call this over here 1/2. And we're looking for our plus or minus values in here. So if we begin to take a look at our what's this called? If we begin to take a look at the derivative here, when we plug our values in, keep in mind that with this x squared in the e portion, no matter what we put in here, this is going to remain a positive number. This will never be negative. So our negative and positive is going to be determined solely by what's happening in the binomial in here. Okay, the 4x squared minus 1. So if we plug in, let's say 0 in this here, because that's nice in the middle, easy to plug in. That's going to clear this out. That's going to make this a negative 1. So this will actually give us a negative value. If we were to plug in 1, this 1 squared becomes 4. Sorry, negative 1. 1 squared, negative 1 squared becomes 1. 4 times 1 is 4. 4 minus 1 is positive. And so this is going to end up giving us a positive. And we can also assume and follow the same steps so that a positive 1 is going to give us a positive number as well. So we can say that this is increasing on the interval of negative infinity to negative 1/2. And it's also increasing on the interval of 1/2 to positive infinity. We can say that it's decreasing between our negative 1/2 and our 1/2. Okay. Now our relative max and min points, this is going to be determined by our critical numbers. Again, we've only got 2 in here, so we're going to kind of focus on those 2. We're going to look at our f of, in this case, negative 1/2. This goes back to the original function, and our f of 1/2. So negative 1/2 in here, this is going to be negative 1/2. So this is going to be 1/2 times, and in this case, e to the negative 2x squared. 1/2. The negative 1/2 x squared is going to give us 1/4. So it still becomes positive. So this becomes a negative 2 over 4, which we can reduce to a negative 1/2. Okay, so this is 1/2 times e to the 1/2. The next one here in our positive, this becomes a negative 1/2 because it's a negative x times, once again, this will be e to the negative 1/2. Now, no matter what number this e to the negative 1/2 comes out to, it's not going to affect the sign. What is this first term here. The 1/2 is positive, the negative 1/2 is negative, which means the negative 1/2 is going to be our minimum, and the positive 1/2 is going to be our maximum. So we can go ahead and write that in. A relative max is actually going to be the points negative 1/2 and 1/2 e to the negative 1/2. And our relative min is going to be 1/2 and a negative 1/2 e to the negative 1/2. And that gives us our solution for this one right here. Okay, the second one over here, we've got a cubic function. We're going to go ahead and take a look at the derivative. We've got our f prime. It's our first step here. This is going to give us 3x squared minus 6x. And then this final one's going to be plus 3. Now, I'm going to factor out a 3 on this. It'll make it a little bit easier to see. This is going to be equal to 3 and x squared minus 2x plus 1. Hopefully you can see that this is actually easily factorable. And so this would end up being 3 times, this would be x minus 1 squared, or x minus 1 times x minus 1. I'm going to call it x minus 1 squared. Okay, we've got this. We're looking for our zeros or undefined. So when our f of x is equal to 0, we set this equal to 0, and we're going to come up with our x is equal to 1. That's the only critical number here. There's no interval to worry about for our endpoints. So we're simply going to say this is 1, and we're looking for our positive and our negative on either side. So let's go ahead and plug in our values on one side or the other. I'm going to choose 0 for the left side. When I plug 0 into our derivative, I'm going to have a positive 3. That's going to be my answer. Okay, so we'll go ahead and look at this. That's positive 3 on that side, or positive on that side. When we look at, by the way, this is our f prime. on this number line. When we look at 2, I'm going to go ahead and plug 2 in on this other side. That's going to give me a 2 minus 1 is going to be 1 squared. That's going to give me 3. That's going to be a positive as well. So in this case right here, we have a positive on both sides, and there is no point in here that indicates that there will be, there's no point in here that indicates that there's going to be an undefined portion. It's not a rational function, so there's no place it'll be undefined. So we're not missing any points. This is going to be continuous all the way along. So what this is, and if you think about how a cubic function works, it goes something like this. So in this case, what's happening is it's leveling off at, in this case, 1, but it's not going down at all. So this is one of those situations in which we have a what's called a monotonic situation. And this is where, I'm going to write this in here before it's a monotonic function. And that means that it's always going up or it's always going down. It's increasing or decreasing 100% of the time. So in this case, it's increasing from negative infinity to positive infinity, and it is never decreasing. Okay, even though this is a critical number, we don't break it there because it never changes direction. The other thing that this means is that we don't have anything that we can use to find a relative minimum or a relative max because it's always going up. So in this case, there's also no relative min or max. Whoops, let's clean that up so it actually is readable. There's no more relative min or max.